Welcome back to the show that tells you you are a quantum computer with free will, making choices that will change the course of the human species. My name is Justin Riddle, and this is episode 39 of the Quantum Consciousness series. In today's episode, we'll be discussing the mechanism of natural selection and how it should probably be updated to reflect the modern information age. By the end of today's episode, we'll ask the question, is consciousness a driving force behind evolution? This episode is available on YouTube, and an audio-only version is available on Spotify and Apple Podcasts. If you like what you hear today, then please like this video, subscribe to this channel, leave a comment below, or for the audio listener, write a review.
Join me deep inside the mystery of numbers. Come and huff a metaphysical. See how concepts become objects and then become qualia. Join us for an episode of Quantum Consciousness.
So evolution is another example of one of these hallmarks within the domain of modern science. We sort of look to evolution as one of the great accomplishments in updating human perception about what's happening in the world around us. However, at the core of evolution is what's called the process of natural selection. And this process is somewhat outdated, somewhat oversimplified. And so the topic of today is not to question the genealogy of species, which is the idea that we evolved from animals and that we've been on this planet for billions of years, slowly progressing through more complex forms of life. So we're not going to question that today, but instead we're going to talk about, what is the driving force behind the evolution of species, culminating in us being here today, these highly intellectual, dexterous beings that we are currently. What is the force that pushes evolution forward fundamentally? And so I will argue today that natural selection, as it was originally framed by Charles Darwin, is quite rudimentary in its framing. This is not a, criticism of the man behind the idea, but really we should be updating and thinking about how we can apply these new concepts that are emerging, like quantum computation, digital computation, this modern understanding of technology that we have. How can we apply this new framework to this more old idea of natural selection? So the format of today is to first describe natural selection to you. Then we will talk about the mechanism behind it and a couple alternatives from the modern era that might replace some of these mechanisms and kind of point out some of the shortcomings or the overly simplified ideas at the core of natural selection. Next, we'll be talking about the idea of gradualism and how this concept of the gradual evolution of the species is the core idea behind a lot of digital chaos-based framings, which I have been pushing back against in multiple instances in this series. So we'll go into this concept of gradualism and some alternatives to gradualism. And then finally, we'll be talking about consciousness and how consciousness represents a really foundational component of organisms of life. And could it be fundamental to the process of evolution, not just this emergent theatrical experience that we're having, but actually a core computational process of the organism, which is at the centerpiece of the force of evolution. So with that is our outline, and we will dive into the first topic, introducing natural selection and the mechanism behind it. Natural selection, as laid out by Darwin, is essentially this complex interaction between an organism and the environment. And so you have these creatures on the planet, they are interacting with each other, There are these predator-prey relationships where animals are consuming and, destroying the life of other animals. And through this process of a interaction with the chaotic environment, the animals that survive and reproduce will pass on their characteristics preferentially to the animals that do not survive, right? This is the survival of the fittest framing for how life changes over time. So we have life forms with characteristics, and they're passing on genes. And back then we didn't have a substrate for this, but now we know that animals have a genetic code. There is a passing off of different genes and a combination between the two mates within that reproductive act, which leads to the formation of a new novel genome, which is a recombination of genetic material from the two parents. And through this genetic recombination, we are told that this is a random process, that there is a random combination of some genes, and then the animal is on a mission now to survive and reproduce in this chaotic, violent environment that it is embedded in. And then when it finds a mate and is able to reproduce, that represents, sort of a ability to survive long enough to reach reproduction. And then the animals that do reproduce will then pass on their genes. And this is the sort of preferred genome as selected for naturally by this environmental interaction. And so there is this ecosystem of organisms battling it out for survival. And through that sort of violent pressure to stay alive in this chaotic world with limited resources and animals needing to consume each other to survive, this is the driving force of how a species will change over time and develop new characteristics. And if we extend this kind of simple mechanism over millions and millions and millions of years, suddenly the multiplication times millions of years and millions of reproductive acts and new animals coming about through reproduction, this is the force that drives the evolution of species from fish into amphibians, into birds and mammals. And there's like this very dramatic transformation in what the life form is, these branching trees of organisms, and it all comes about through this genetic recombination and the environmental pressure to stay alive enough or long enough to reproduce. Now, there have been some modern rebrandings of this process. So instead of survival of the fittest, some people will say, well, it's really survival of the most cooperative, where animals that work together will have a better chance of survival, and it's a social reality. And so you have these societies forming in these, in the animal kingdom and then in our modern era. And, through cooperating, you don't need to be strong, but you could serve an important social function or an important function within a community. And then that would allow you to pass on your traits. So it's kind of updated the system a little bit to be more amenable to these, less violent forms of society where you still have mate selection, you still have other pressures that are driving choice between who gets to reproduce and who does not. What then is the fundamental mechanism behind all of this, and is this sufficient? And what I'm going to argue to you today is that we have yet another instance of this simple sort of first order logical system where you're going to have a random process, quote unquote, and you have simple physical constituents that are going to be randomly combined with each other. And then through enough random smashing together of components, you will have the chaotic emergence of something that works, some complex organism. And I think the challenge with this is we have this instance where we're taking a very simple process and then we're saying, multiply it by 1,000,000 years, multiply it by a bunch of random combinations, and then suddenly there's enough driving force to build something out of nothing. Through the chaos, we have an emergent form which has some stability, and that stability is, randomly emergent, but once it exists, maybe it can sustain itself and then serve some function, and you can build on top of the things that you've created. However, mechanistically, this is no different than early notions of behavioralism in psychology. So in behavioralism, we have this idea that you can have a stimulus and a response pairing. And the classic example is reinforcement learning with Pavlov and his dogs, where you have dogs that salivate to food. You start ringing a bell when you give the dog food, and then over time you can just ring the bell and the dog will start to salivate because you have built up enough propensity of a paired association between the food and the bell such that the dog will make that association, and we have now built up a system of logical connections from nothing that are kind of arbitrarily built out of random pairings in the environment. And this is like the core mechanism of how all of cognitive function and all of this complex stuff in the brain, all these complex behaviors emerge. And the problem with this is that there is just not enough instances of things occurring in our life to build up these associations. So on one level, there's just the mechanism is so simple and requires so much iterative repeating of the situation to build even the simplest of connections. So that's one knock against it. And then the second knock against it is that this is such an overly simple mechanism of building information and building some network of connections that the very concept of building associations out of simple, random, arbitrary pairings is just not a very computationally robust way of building anything out of this, chaotic milieu of random things occurring, right? So there's been many, many attempts where people think, okay, this is a simple mechanism, and yet when we scale it up, when we add complexity, we add enough iterations, enough instances of building these connections, we will have enough complexity where something meaningful emerges. And the problem with this framing is that we've tried this over and over and over again throughout the history of science, and these mechanisms are just not sufficient to build up anything of much value. And this idea is summarized quite well in the book What Darwin Got Wrong by Jerry Fodor and Massimo Piatelli Palmarini. This book really spells out that this classic idea of behaviorism, where we can build up a system of arbitrary associations, is roughly the same mechanism at play in natural selection. We have since realized that this mechanism is too simple to capture the complexity of human experience that is acquired in such a brief period of time. And yet, for certain pillars of science, like natural selection, the same mechanism is at play. And while we recognize the shortcomings for psychology, for the cognitive sciences, there is a little bit of a holdout in the domain of evolutionary theory because it's just been in place for so long, and there's just kind of this notion that we just can't challenge the tenets of evolution as specified in the 1800s. And I feel like this is just kind of a, politicalized topic to some degree. People think you're like challenging evolution fundamentally in some like core way. However, we're not necessarily doing that. We're just saying, what is the actual mechanism behind evolution? And I would be shocked if we found the proper mechanism, over 150 years ago, pre-computers, pre-quantum computers, pre-modern understanding I mean, there's probably no way that we had it figured out in the 1800s. So on some level, I think it's, obviously not that controversial to challenge this very simple concept of building up random associations. We talked about this multiple times in talking about digital computers, talking about digital artificial intelligence. Many episodes spent talking about how the domain of randomly combining things has been repeatedly proposed as a solution. And yet, when you start thinking through combinatorics, just the sheer volume of possibilities in any very simple system, if you have one or two stable formations of a system, the chance that you're going to randomly stumble upon the correct formation is extremely, extremely low. And because of these vast, exponentially large search spaces that we would need to search through to find these stable forms, it's not feasible in any sort of way to just go try out a bunch of random stuff until you happen to get something that works and then you stick with it. It's just so unlikely to come about something stable. And yet, because it's simple to comprehend and because it doesn't require much imagination, this is often viewed as sort of like the default way that things must be happening. However, we try to build tools with these concepts and it doesn't work. Okay, so what is the alternative here to this everything's random, everything's arbitrary, and things just get paired together? So I'm going to go through a couple options that are alternatives here. One of them is sort of a reference to Platonism, to a domain of mathematics that kind of transcends randomness, but actually has like some logical, meaningful structure behind it. And the other is an appeal to computational systems that do not rely necessarily on random forces, but have some sort of computational push. And I'll, make a very classic argument for this channel that quantum computation is a great candidate for something that might be a driving force, as opposed to digital computation, which has some other limitations, which we'll come back to in a second here. So what is some of the problems here? Into our second topic, one thing that Darwin really pitched was this idea of gradualism. All right, so here I'm going to read a brief quote by Charles Darwin from On the Origin of Species, and he says, "If it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous successive slight modifications, my theory would absolutely break down." All right, so this is quite a noble claim where essentially, if we're designing a good theory, we should provide room to falsify that theory. In this example, Darwin has kind of put forth this idea that through this random genetic recombination process, through survival and mating, you are going to build complexity. He provides that, this process is going to very slowly, iteratively, gradually build upon previous discoveries in the species, and you will slowly build up to having some new property. Many examples we could think of. One of them is like a giraffe. Why does a giraffe have a long neck? Well, the giraffes with longer necks were able to eat from the trees that were a little bit higher, and so that gave them a survival edge relative to the other giraffes, and then they reproduce more frequently, randomly genetically recombined, and then their children were more likely to have slightly longer necks, and so on and so forth, and we can gradually build up this long-necked giraffe through many, many iterations, many lifetimes of species. All right. However, one of the challenges here is, for example, flight, or the ability to breathe air not in the ocean, right? There are certain functions of the body that seem to be sort of holistic processes in and of themselves, that there would be no purpose to having half a wing or a lung that could that I don't even know how lungs would slowly transition. Maybe someone out there knows of a way that this could be possible. But, when you can fly, this is a, paradigm shift between not being able to fly. Suddenly, aerodynamics matter. Suddenly, there's all these new forces that need to be managed. The brain needs to have systems for navigating long distances, not short distances. There needs to be control over flight, So there's essentially a lot that comes along with flying that is not present before flying. So the argument here is that if we take this gradualist approach, it's challenging to think how you would have these entire updates to a system that seem to be, irreversible or represent a fundamental change in function well beyond, something that was happening previously. This is hard to conceptualize if we have a random chaotic system. However, there are other ways to conceptualize what does it mean to have a biological system. So one shift, and this is very common in modern physics, and I've talked about this numerous times on the channel, but I'll reiterate this briefly, is this idea of Platonism. Okay, it's this idea that there is a domain of mathematics, of meaningful constructs, which we are able to tap into in some way, and these forms, these mathematics are governing our universe, our physical universe. And so in a weird way, this is different from any given physical instance. You can also imagine there is the laws, the mathematics governing behind the scenes, moving that particular physical instance. So we can have some arbitrary physical, system over here, and then we can have some universal law that governs many different arbitrary physical systems, and it is the same law, right? There is a force of gravity, for example, which permeates all of the universe, and everywhere, all things are subject to that force. So now the question is, most people do not like this concept of Platonism, and so they're resistant and say, well, we're not going to separate physical reality as it is from the forces behind and governing physical reality. Somehow they're just the same thing. I think this is somewhat wishful thinking, kind of shoving these things together, these very different concepts together. But if we were to take this Platonic world of forms, the mathematics, the laws, the logos or logic behind the universe as a separate entity from any physical instantiation, evolution becomes an interesting interplay where the physical world can sort of tap into or be governed by different mathematical processes. So, for example, there are certain laws around aerodynamics which could kind of find their way into the biological system. We see the manifestation of geometric patterns, fractal mathematics in a lot of different organisms. It looks like there's some computational principle at play. And so one way of conceptualizing these Platonic forms is to say that these are like computations that are being run, right? You can have an arbitrary digital computer, and yet the process of that digital computer could be running addition or subtraction, trigonometry mathematics, right? There's all sorts of computations that could be taking place, and those computations could be more or less useful based on these computational properties. And this has nothing to do with like the physical things randomly smashing into each other to build up something random, but instead there's some sort of manner in which biology is enacting computational processes, and then you're not arbitrarily at this physical level, but you're arbitrarily maybe smashing computational forces together, right? And so you could have a biological system saying, I'm going to try out this computational function and then this other computational function. And there's a little bit more to work with from that reframing into more of a computational Platonic-y lens. And I think at the time when natural selection came about, the best we could conceptualize was just random forces smashing into each other to create genetic combinations of things, arbitrary structures. However, in this modern digital computer age, I think we could imagine that it's the same infrastructure, but different computational processes that are being carried out. And this is a way of updating the system. So instead of having a gradual change, you could have a new computational force that is enacted, and then that would be sort of a paradigm shift in the species where suddenly we're tapping into flight computations instead of just randomly smashing particles together until a wing starts getting chaotically formed. We start playing around in the domain of computational principles, and then we stumble into some sort of flight adjacent, flight related computation that starts manifesting into the body to build out certain organs or build out certain systems. And this is a little bit more of a dynamic interplay between a computational force and then a physical reality. So maybe this is somewhat subtle, but I feel like we could operationalize some of these ideas within the modern digital computer information age, where it becomes a little bit less abstract, moving out of this, everything is physical and randomly smashing into each other. But I feel like living in the information age with the internet and these computers around us, we can more so imagine software being run, different combinations of software that are being enacted. And that is sort of an upgrade in the metaphors and the mechanisms at play than just random forces, right? Random physical stuff being recombined. And for historical context, there was a scientist called Jean-Baptiste Lamarck, and he was a contemporary of Charles Darwin, and he was pitching this idea that you could have more dramatic moments of updating of a system. And this would be a sort of challenge to gradualism, where you need to very slowly, iteratively build something up, but instead you could stumble into a more paradigm shift within the system. In addition, Lamarck believed that the choices of the individual within the species made an impact on evolution. And this critically translates us to our third topic, which is the relationship of consciousness to evolution. So Lamarck said that the individual within a species would make decisions about how to use its body, how to interact with the world, and those choices made an impact back on the body and irrevocably changed the physical system. And then that got passed down to the next of kin in a very real way. And what's really cool is we now have more direct evidence that this is more or less occurring. This is what is called the field of epigenetics. This is how we now have evidence that within the life of an individual, you will have choices or experiences that occur, and then through those experiences, there will be a change made to the DNA itself as an experience-dependent process. This isn't necessarily a direct editing of the genome by the individual, but instead there is a alteration of these proteins that are bound to DNA, and this changes how the DNA is used, right? So it's not a shift in genetic code itself, but we now know that a lot of what is important about DNA is it's how you use it, and not always or not necessarily that the DNA itself is sort of the algorithm running the body, but instead it's kind of a recipe book with guideposts for what to use and what not to use. And those guideposts of what to use and what not to use could be dynamically edited and changed through the experience of the organism. This means that your choices as an individual are very real and altering and changing your genetic expression. And this could be something passed down to next of kin, okay? So this is sort of validating a lot of these Lamarckian ideas that the experience of the individual is important. And so let's contrast this with Darwinian natural selection, where nothing happens in the life of the individual. All that matters is basically reproduction and violent death. Like these are the forces of the universe. Are you reproducing and are you surviving? And only upon reproduction with recreation is there any change in the species whatsoever. Your life doesn't matter. It's just, did you have a baby or not? And then is that baby going to survive or not? Right? It's kind of a very brutal framing of reality, but it kind of is strange because here we are living these 60 to 90 to 100 year lives, and yet all that matters is if you had a kid when you were, in your 20s or 30s or whatever. That act is all that matters. And then, okay, we just hang around for 40 years, 30, 40 years. And what's the point of just hanging around? I guess it doesn't do anything, right? We're just here for the ride and we're just floating, and we just happen to live longer than recreation. And if you don't reproduce, then you are suddenly in violation of all of your drives as an individual contributing to the species, right? These are kind of the brutal consequences of this very natural selection focused framing. Now, this is partially addressed by Lamarckian evolution because you can epigenetically change the expression of your genetic code. And then through that life experience, your choices did matter. Your choices did make a difference on some level. But, it still kind of ends when you have a kid, when you make babies. That is the end of your influence on the species. You could contribute to these environmental pressures on some level, but really it is still very procreation focused. The alternative here is, on one level, it is viewing consciousness as a core computational process driving the individual and meaningfully changing the system. And two, it is an expansion of the goal state of what the species is working towards. So to that first point about quantum computation, one of the major pitches of quantum consciousness, of viewing the mind as a quantum computer, is that your mind, your experience, is the fundamental computational process of the body. There is a mind in the body that governs and changes the behavior of the system, and we are thoughtfully thinking through what to do with our choices, and that thought process is a quantum computation evolving some inputs and generating some meaningful transformation of that data into an output state. This is some sort of learning process, acquiring data from the environment. Maybe this is like a Bayesian learning, which we talked about, gathering data, assembling a worldview, assembling a system of beliefs and thoughts, and then acting upon the world according to our beliefs and thoughts and values. And when you sit there and think about something, you are computing, you are quantum computing, you are changing the organism, you are essentially evolving through time and meaningfully changing the system in some way. So then from this framing, your mind is a part of the evolutionary computation because your mind is the core computational process evolving from one state to the next, changing behavior, contributing to this ecosystem, to this environment, and potentially epigenetically altering your own genetic expression, Maybe there's more dramatic ways that our thoughts are changing the body, right? We know that there's a powerful stress-disease connection where if you're stressed out, you're generating disease in your own body, or you're more susceptible to disease, right? There's a lot of ways that our mind will change the state of the body, and I don't think we fully appreciate or understand just the degree to which our mind is meaningfully interacting with the physical biological system that we have. Once again, it's controversial to even say that you're real, or to say that your choices are making a difference in your biology, or that your mind is a computational process in and of itself. So I think just updating evolution, natural selection to acknowledge the experience of the individual as meaningfully changing biology in addition to changing the environment that we are embedded within. I think that is a great first step. One argument for quantum computation is that, and we'll talk about this again in a very future near episode that's about to come out, that quantum computation might be a more easy to occur natural process than building naturally occurring digital computers, which arguably we don't have evidence of naturally occurring digital computers aside from, us creating them in this very artificial way. Quantum computation doesn't necessarily, or might not, require a programmer, whereas digital computation is very susceptible to errors, susceptible to breaking. It seems really hard to imagine how digital computational forces would randomly occur. However, quantum computation might be a way to build informational complexity, to naturally process input and generate some meaningful output. So from that perspective, when we go back to the core of natural selection, where do we start, right? How do we start combining random things to even get a working organism that's able to reproduce and fight for its survival? Quantum computation might be an answer to how we could assemble an organism that is computing and processing information in some meaningful way. So that is a pretty big deviation from the principle of natural selection. And then finally, I think we need to think critically about what is the goal state of the species. If you want to take Darwinian evolution to its inevitable conclusion, you end up with Richard Dawkins' the selfish gene. This idea that we are just genetic code driven to copy itself and multiply genetic code arbitrarily, right? This is a very bizarre motivation that humans would have. And then it begs the question, for people who choose not to reproduce, are they in violation of the selfish gene? If this is really the core of our purpose, just to genetically copy ourselves, I feel like there's just so much evidence from modern society that violates this very simple idea that we are just replicating machines. So the alternative is that your mind is real. We're evolving. We're reverse engineering the human mind potentially in our technologies, right? We recently created the internet. We're on the cusp of building quantum computers, right? We're at this knee of the curve of exploding technological advancement. And the human mind, we're starting to realize, might be a much more core driving computational force in reality. When a human, commits their life to education, to building human understanding, is that real in any way? And I would argue that yes, it is, right? If we say that the Platonic world is real, that there's a domain of mathematics, of meaning, and we have people growing and building meaning, figuring out how the universe works. Figuring out how the universe works could be a core process, a core function of humans. And then we can share those ideas with each other, and then that changes other people's lives, right? We live in a society, in a community, and we are building and storing human knowledge. I mean, this is an entirely different force of nature than just copying genetic code. We are figuring out why we're here. We're figuring out what's going on. We're learning to build computers. We're learning to interface with our biology more carefully, more nuanced to promote health. These are like non-negligible forces in reality that we are actively contributing to. And why would that not be a goal state of the species? Why would that not be something that we are evolving towards, right? The creation of a flourishing society, of reverse engineering biology, these could be goal states beyond just raw replication. And the process that is getting us to that place could be quantum computation, could be human consciousness as a evolutionary force moving the organism from the past into the future. What is at the core of life, of this planet coming out of, the galaxy and becoming this force of life? If we roll back time, what is pushing us forward? And one thing for me that I have found very inspiring are these new framings of human consciousness as a quantum computer, as something computing and creating and pushing information into the future, assembling information, assembling meaning. This is something that should give our lives more importance, more meaning, whether or not we decide to have children, right? There's a lot to this life, and there's a lot to this experience that isn't captured in Darwinian natural selection, survival of the fittest, right? So it was a great working model. It's a great foundational point for us to update and improve upon this system of, figuring out how life came about on this planet. So I'll leave you with that. Food for thought, something to think about, and I will talk to you again really soon.